Hello everyone, welcome to easyedu, and today we are going to solve the first 6 numericals of chapter number 2 of first year physics. Numerical number 1 is a person throws a ball straight up with a speed of 12 meters per second. If the bus is moving at 25 meters per second, what is the velocity of the ball to an observer on the ground? So it means that the person is traveling in the bus. So the velocity of the bus is 25 meters per second, and the velocity of this person will also be equal to 25 meters per second, and similarly the velocity of the ball before throwing will be equal to 25 meters per second with respect to an observer on the ground. So this is actually the x component of the velocity, and the x component of the velocity is denoted by Vx is equal to 25 meters per second. Now when the person throws the ball upward, then that will be the y component of the velocity, and the velocity will be equal to Vy is equal to 12 meters per second. So this is the y component and this is the x component of the velocity. We are going to calculate the velocity of the ball to an observer on the ground. To an observer on the ground, the velocity of the ball will be equal to the sum of these two velocities, but these velocities are actually in components form. This is the x component and this is the y component. So we are going to calculate the magnitude of the velocity, and the magnitude of the velocity will be the velocity of the ball with respect to an observer on the ground. Now for calculating the velocity, the magnitude of the velocity, we are going to use a Pythagorean theorem. According to the Pythagorean theorem, the hypotenuse whole square is equal to base square plus perpendicular square. So from this free body diagram, we have the hypotenuse v, which we are going to calculate. The x component is 25 meters per second and the y component is 12 meters per second. Substituting the values and solving, we will get 27.3. Now rounding of this 3 will drop. This is actually 27.73. Now rounding of this number, we will drop this 73 and increase this 27 to 28. So 28 meters per second is the answer, and that is the velocity of the ball with respect to an observer on the ground. That's it. Now the numerical number 2 is a football leaves the foot of a punter and an angle of 54 degrees with respect to x direction at a speed of 21 meters per second. Now here the velocity of the ball is given as 21 meters per second, the angle is given as 54 degrees, and it says that determine the horizontal and vertical component of the velocity. So we are going to calculate the x component, which is the horizontal component, and the y component, which is the vertical component of the velocity. So we will calculate Vx and Vy, and theta and magnitude of velocity is given. Now here we have the free body diagram. Here we have velocity 21 meters per second, theta 54 degrees, and we are going to calculate Vx and Vy. So there are simple equation. One is Vx, we know that the x component this is equal to V cos theta, and the y component we know is equal to Vy is equal to V sin theta. So we will substitute the value for V and theta in this equation, and we will get Vx is equal to 21. 21 is the velocity, cos 54, which is equal to 12 meters per second. This will be the x component of the velocity. Similarly, for the y component of the velocity, we will put the value of v and theta, which is 21 sine 54, and we will get 17 meters per second. That is the y component of the velocity. That's it. From where came this equation? This equation came from the cos theta, which is equal to base divided by hypotenuse. Using that simple equation, you can derive this equation and this equation. These two equations are part of the resolution of vector. Now we are going to solve numerical number 3, which is a 1.84 kilogram school bag hangs in the middle of a clothesline, causing it to sag by an angle theta is equal to 3.50 degree. Find the tension T in the clothesline. This is the clothesline. This bag hangs from this clothesline and it is making an angle of 3.50 on this end. Similarly, the angle on this end will also be equal to the angle on this side, and the angle on this side will be equal to the angle on this side and this side. So we have making this new triangular shape. Here we can see that this bag is balanced by the tension Ty and Ty2. These two tension balance the weight of this bag. So we have the sum of all the forces on this bag. This is in equilibrium position, and this T sine theta, this Ty is equal to T sine theta. The y component Ty allocate to this triangular shape. In this triangular shape, this is the base and this is the perpendicular. So this Ty actually represent the perpendicular, and the perpendicular Ty is equal to T sine theta. Similarly, for this T2y, this T2y is also equal to T sine theta, because all of these sides are equal. So we have T sine theta plus T sine theta. This Ty and this Ty is equal to mg. Mg is the weight or the force due to the mass of this bag, and that is equal to mg. We know mass is the a kilogram and g is the gravity. So mass times gravity is equal to Newton, which is force. Now these two terms will add up with each other and we will get 2t sine theta is equal to mg. We will solve this equation for the value of tension T. Solving this equation for tension T, we will have T is equal to mg divided by 2 sine theta, and now substituting the value for mass, which is given as 1.84 kilogram. We know that the gravitational acceleration is 9.8 meter per second. 2 is this 2, and sine theta is given as 3.50 degree. Now solving this, we will finally get 148 Newton, and this 148 Newton is the required tension T in the clothesline. That's it. Now according to the numerical number 4, which is find the magnitude and direction of vector represented by the following pair of components. These two pair of components are given as, and from these two pair of components we will calculate the magnitude and direction. The magnitude can be calculated by using Pythagorean theorem, and the direction can be calculated by using tangent theta. So these are actually the components. This is minus 2.3 centimeter and this AY is given as 4.1 centimeter. This AX and AY both are vectors, and this negative sign means that the X is negative. When the X component is negative, then this will either lies in the second quadrant or in the third quadrant, but here the Y is positive, so it means that this vector lies in the second quadrant. Now for solving or calculating the magnitude, we will use the Pythagorean theorem. That is simple. We will use a square is equal to base square plus perpendicular square. Consider this as a base and consider this as a perpendicular. This is the y component and this is the x component, and we are going to calculate the hypotenuse, which is denoted by a. So we will have a square is equal to 5 minus 2.3 whole square plus 4.1 whole square. Solving this, we will get a is equal to 4.701 centimeter. Now for calculating the theta, we know that tangent theta is equal to y divided by x. Here the y component is this 4.1 and the x component is minus 2.3 centimeter. So we will have theta is equal to tangent inverse y divided by x. Substituting the values, we will get finally minus 60 0.7 degree. So this minus 60.6.7 degree, this lie in the second quadrant. So we will substitute. If we consider this whole angle, then we know that this is equal to 180 degree. So we will subtract this 60 degree from this 180 degree. By subtracting this, we will get this angle, and this angle is the required direction. This angle will be equal to 119.3 degrees, and that is equal to 180 minus 60.7. Now from the second part, we know that this is 3.9 meter and this is minus 1.8 meter. Again, here this is the x component and this is the y component using Pythagorean theorem, that is a square is equal to ax square plus ay square, or base square plus perpendicular square. We will have 3.9 whole square. 3.9 whole square is the x component square, and minus 1.8 whole square is the square of the y component. Now taking here the under root, solving this and then taking the under root, we will get a is equal to 4.3 meter. Now this 4.3 meter is the magnitude for this part B of the numerical. Now we are going to calculate the theta, and theta, again we know that tangent theta is equal to y by x. Theta is equal to tangent inverse y divided by x. And then substituting the values for y and x and solving, we will finally get minus 24.77 degree. Now this minus 24.77 degree, what we are going to do is we are going to subtract this value. We are going to subtract this value from the 360 degree, because of this pair, this ax and ay. This vector lies in the fourth quadrant. The fourth quadrant means this is positive, x is positive and the y is negative. When the x is positive and the y is negative, then the vector lies in the fourth quadrant. So when this lies in the fourth quadrant, we will subtract this value from 360 degree. By subtracting this value from 360 degree, we will get 335.22 degrees. So this will be the angle or direction which is required in the answer. That is 335.22 degree. That is the required answer. Now according to numerical number 5, a vector f having magnitude of 5.5 Newton makes 10 degree. The angle is given and the magnitude is given with the x-axis as this is making a 10 degree, and the magnitude of this is given as 5.5 Newton. Now the vector r is given having magnitude of 4.3 meter. This is vector f and this is vector r. The magnitude of vector r is given as 4.3 Newton, and the angle of this vector r with x-axis is given as 80 degree. Theta is equal to 80 degree. This theta is 10 degree. Now what we are going to do is we are going to calculate the magnitude of their dot product and cross product. The dot product is also known as a scalar product, and the cross product is also known as vector product, because the cross product gives us a vector quantity and the dot product gives us a scalar quantity. Now for dot product, we know that a dot b, the dot product between two vectors a and b will be equal to ab cos theta, and the cross product between two vectors a and b will be equal to ab sin theta. Now what is this theta in this equation? This theta is the angle between vector a and vector b. Now we are going to take the dot product of vector f with vector r. By taking the dot product, we will have f dot r is equal to fr cos theta. Now this theta is the angle between vector f and vector r, this angle, and this angle will be equal to as this angle is 80 degree and this one is 10 degree. By subtracting this 10 from 80, we will get 70 degree, and this 70 degree is actually the angle between vector r and vector f. So we will have theta is equal to 70 degree. Substituting the values and solving, we will get f dot r is equal to 8.08, which is equal to 8.1 nanometer, 8.1 Newton meter. Now this dot product is energy or work. Now this is a cross product. We are going to take the cross product between force F and vector r, or radius r, that will give us that will give us torque, that is F cross r. So we will have Fr sine theta. F is given as 5.5 Newton. This is Newton, and this is meter. This is meter. So we have 5.5 Newton multiplied by 4.3 meter into sine 70 degrees, and solving this, finally we will get 22.223, which is equal to 22.2 Newton meter, and this 22.2 Newton meter is torque, and this 8.1 Newton meter is work or energy. Now according to the numerical number 6, that is the magnitude of dot and cross product of two vectors is 6 under root 3 and 6 respectively. Find the angle theta between the vectors. So a dot product of two vectors a dot b is given as 6 under root 3. This is given that the dot product between two vectors a and b is equal to 6 under root 3, and the cross product between vector a and vector b is given as 6. We are going to calculate theta, the angle between this vector a and vector b. Now we know that a dot b is equal to ab cos theta and a cross b is equal to ab sin theta. Now divide that second equation by equation number 1. By dividing second equation by equation number 1, we will get a cross b divided by a dot b is equal to ab sin theta divided by ab cos theta. This ab and this ab will cancel out with each other, and this sin theta divided by cos theta we know is equal to tangent theta. So we have tangent theta is equal to a cross b divided by a dot b. A cross b is given as 6, which is equal to 6, and a dot b is equal to 6 under root 3. So a dot b is equal to 6 under root 3. Substituting the value for a cross b and a dot b, we will have 6 divided by 6 under root 3. This 6 and this 6 will cancel out with each other, and we will have tangent theta is equal to 1 over under root 3. Now taking the inverse tangent, we will have theta is equal to tangent inverse 1 over under root 3, and tangent inverse 1 over under root 3 is equal to 30 degrees. So we will have the direction or theta, or the angle between vector A and vector B is equal to 30 degree. And this is the required answer. That's it. Thank you for watching, and don't forget to subscribe easyedu for more videos.